everyone. Today we are going to solve the third section, choose 3 of Interviewbit. Now the first question goes like this. We are given 4 loops. We have to find the most efficient one. Now let's take a look at the first loop. How many times does this loop execute? The I value is initially 0, then it becomes 1, then it becomes 2, and so on until it becomes n minus 1. So how many times does this loop execute? It is n times. So it is basically order of n. And now let's go to the second loop. Initially I is 0, and then it becomes 2, then becomes 4 until n minus 1. So if you have a close look at this, you can decide that these are all even numbers until n minus 1. They would be approximately n by 2. So this loop executes n by 2 times. We can also say that this is big O of n. But comparatively from the first loop, this loop executes faster. And now let's take a look at the third loop. Initially I is 1, then I becomes 2, then 2 square, then 2 cube, and so on until 2 power k. So we have already done this in our previous videos. You just have to equate 2 power k is equal to n. This is where the condition breaks and k becomes log n. So how many times did this loop execute? This is log n times approximately. So this is big O of log n. And finally the fourth loop. This is pretty interesting case. Initially I was 1, it becomes n by 2, and then it becomes n by 4, and so on. When does this end? The condition is I greater than minus 1. Can this ever be less than 0? No, it can't be, because the n goes on reducing, and when it reaches 0, 0 by 2 is 0, and then 0 by 2 is also 0. It goes in an endless loop. So this loop goes forever. It doesn't end. So which loop is the most efficient one? Yes, this third one is the most efficient one. And let's go to the next question. Which of the following is not bounded by O of n square? Here we are given 4 options. In the first option, this is of the form C1 into n plus C2. It's basically big O of n, and this is n power 1.98. So this will be big O of n power 1.98. So these two are bound by big O of n square, because this is less than n square and this is also less than n square. And let's take a look at the third one. This is n power 3 by n power 1 by 2, which is n power 3 minus 1 by 2. 3, 2 3 are 6 minus 1. This is n power 5 by 2 is equal to n power 2.5. This is O of n power 2.5. O of n square, this is not bound by O of n square. This is greater than it. Now let's come to the fourth one. This is of the form constant into n, which basically is O of n. This O of n, this is also bound by O of n square. This is the only one which is not bound by O of n square. And finally the last one. And these kind of problems can be easily solved using substitution method. The trick is you substitute a very huge value, a very large value in the place of n and compare the values of the functions. Let's take n is equal to 2 power 1024. I have taken a very large value. And why have I taken 2 power 1024? Because there are logs, so that we can calculate easily. And f of f1 becomes 2 into 2 power 1024, which is 2 power 1025. This is a very huge value. No, this is not into, this is 2 power 1024. This is a very huge value. And f2 of n is equal to 2 power 1024 power 3 by 2. 2 ones are 2, 5 tens are 5 12s are, and this gives us 2 power 5 3s are 15, 1536. This is also a very huge value, but less than the previous one. This is 2 power 1024. And coming to the third function, 2 power 1024 into log of 2 power 1024. Log of 2 power 1024 is 1024. 1024 into 2 power 1024. This is the third function. And coming to the fourth, 2 power 1024 whole power log 2 power 1024. Log of 2 power 1024. This is log of 2 power 1024 is 2 power 1024. 2 power 1024 into 1024, which is, now compare the values. And this is the most highest one, and the second one is this one, and the third one is, wait a minute, this is the second one. First, second, third, fourth. The order is f1. We should write them in increasing order, right? So the first one will be f3, then f2, then f4, then f1, f3, f2, f4, f1. Thank you for watching this video. Thank you very much.